In this video, I want to share the mathematical concept of algebraic fractions. So I'll go through a brief conceptual overview and then go through some practical problem solving. So let's jump straight into the video. I'll focus on the topic of algebraic fractions, but before going into the problem solving, I'll just give a brief overview. So if I go to Google and go to Google and type algebraic fractions with these two keywords, the AI overview is algebraic fractions are fractions where the numerator, the denominator or both contain algebraic expressions. So the numerator or the denominator or both will contain algebraic expressions. So what are algebraic expressions? Expressions with variables and constants. So if I give a cider explanation, the algebraic fraction is a fraction where the numerator and denominator are algebraic expressions. So you get the idea that an algebraic fraction is a fraction where both the denominator and the numerator contain algebraic expressions. So this is the brief overview of what algebraic fractions are. So if I go to the first problem, there are three category problems here: medium, hard and very hard. I'll focus on the hard part. So if I go focus on the first problem, you have to simplify fully this expression, which is an algebraic factor containing algebraic expressions. So both the denominator and numerator has algebraic expressions, so you have to simplify this expression. So let me write these expressions, which is 2x square, which is what? The numerator is 2x square minus 5x plus 3. 2x square minus 5x plus 3 divided by the denominator is x square plus 5x minus 6. x square plus 5x minus 6. So you can use middle term in both these cases. So if I use the middle term in the numerator, 3 multiplied by 2 is 6. So we can write 6 as what? 6 as a multiplication of 6 as a multiplication of minus 3 and minus 2. Because minus 5 is there, we can write minus 3 and minus 2. Divide the middle term, okay? Or split the middle term rather. So we can write 2x square minus twice x minus thrice x plus 3. And in the denominator, we can write x square plus 5x minus 6. So minus 6 multiplied by 1 is what? Minus 6. So we can write 5x or split 5x into minus 6 and plus 1. So we can write x square or minus plus 6 and minus 1. So plus 6x minus x minus 6. So plus 6x minus x is plus 5x. So now we can create factors. So twice x square plus minus twice x. If we take twice x common, we get what? X minus 1. And in thrice x minus thrice x plus 3, if we take minus 3 common, we get what? X minus 1. Right, minus thrice x plus 3. Okay. And in the denominator, if I take x common, x into x plus 6, minus 1 into x plus 6. Okay, so now we can write what? We can write twice x minus 3 multiplied by x minus 1. So x minus 1 multiplied by twice x minus 3, and we can write x minus 1 multiplied by x plus 6. So we can cut off x minus 1. So we get what? We get a factor of twice x minus 3 divided by x plus 6. So this is the simplified expression of the factor, this factor, which has both algebraic expressions in both numerator and denominator. I'll focus on problem number 3, which states you have to simplify this expression x square minus 16 divided by twice x square minus 5x minus 12. So if I use my pen tool, the algebraic fractions. So if I draw using the pen tool, the expression is x square minus 16, x square minus 16 divided by 2x square minus 5x minus 12, twice x square minus 5x minus 12. So for the numerator or the x square minus 16 expression, I can use the formula of a square minus b square. Okay, so if the formula of a square minus b square is a plus b into a minus b, so I can write x plus 4 multiplied by x minus 4. Okay, x square minus 4 square. So x plus 4 into x minus 4. And for the denominator, I can use the middle term. So 2 multiplied by minus 12 is minus 24. So how can I write minus 5, the middle term, minus 5x, as 24? Minus 24 can be used as 8 and 3. 8 and 3 can be used. So twice x square minus 8x plus thrice x minus 12. So minus 8x plus thrice x is what? Minus 5x. So I can write this as twice x multiplied by x minus 4 minus 3 plus 3 multiplied by x minus 4, and the upper part is obviously x plus 4, x minus 4, x plus 4 multiplied by x minus 4. Okay, so I have the denominator as what? X minus 4, x minus 4 multiplied by twice x plus 3, and the numerator is x plus 4 multiplied by x minus 4. So I can cut off x minus 4, so I get what? The factor is x plus 4 divided by twice x plus 3. This is the simplified factor expression, algebraic expression of this expression. So this is what was required in the question. Now I'll focus on problem number 5 of the harder category. You have to show that this expression twice x square minus thrice x minus 5 divided by x square plus 6 plus 5 can be written in the form x plus b divided by cx plus d, where a, b and c and d are integers. So if I write this problem, the expression is 2x square minus 3x minus 5. So twice x square minus thrice x minus 5 divided by x square plus 6x plus 5, x square plus 6x plus 5. Okay, so you can use middle term in both the numerator and the denominator. So if I use the middle term, minus 5 multiplied by 2 is 10. So I can write 10 as what? 5. I can use 5 and 2 because 5 and 2 can get the result minus 3x. So I can write twice x square minus 5x plus twice x minus 5. Okay, or I can write twice square plus twice x minus 5x minus 5. Okay, so the denominator I can write, because 5 multiplied by 1 is 5, so I can write 5 as 5 and 1. So x square plus 5x plus x plus 5. If I write this as what? Twice x square, then I can take common twice x. So twice x, if I take twice x common, I get what? X plus 1. And if I take minus 5 common from minus 5x minus 5, this part, I get what? Minus 5 multiplied by x plus 1. So minus 5x minus 5, and here I can take x common. So x plus 5, x multiplied by x plus 5 plus 1 multiplied by x plus 5. I can write the whole expression as what? X plus 1 multiplied by twice x minus 5, x plus 5, the denominator is x plus 5 multiplied by x plus 1. I can cut x plus 1 from both denominator and numerator, so I can get what? Twice x minus 5 divided by x plus 5. So this can be written as what? This can be written as, because we have to show that ax plus b cx plus d, so this can be written as a, or 2 multiplied by x plus minus 5, which is b, divided by cx, or 1 multiplied by x plus d, which is 5. So this is a, this can be represented as a, this can be represented as b, which is minus 5, this can be represented as c, and this can be represented as d. So it can be represented as ax plus b into cx plus d, which was required in the question. Now I'll focus on problem number 9. So you have to solve this equation, 4x minus 3x divided by 5 minus 3x minus 5 divided by 2 equals minus 3. So let me write the problem. So you have to solve the equation. 4 minus thrice x divided by 5 4 minus 36 divided by 5 minus 36 minus 5 divided by 2 minus 36 minus 5 divided by 2 equals what? Equals minus 3. Equals minus 3. You have to solve this equation. So how can you solve this equation? You can solve this equation if I take common 5 and 2, so I can take 10 common. So 10 divided by 5 is 2. 2 multiplied by 4 minus 36 is what? 8 minus 6x minus 10 divided by 2 is 5. 5 multiplied by 36 minus 5 is what? 15x. 5 multiplied by 36 minus 5. So 15x plus minus 5 multiplied by 36 minus 5. Minus 5 multiplied by 36 is minus 15x, and minus 5 divided by multiplied by minus 5 is plus 25. Okay, so this is the multiplication, then equals minus 3. So 5 multiplied by 36 minus 5. Okay, so then I can do what? I can take 10 here and multiply. So I get what? Here 25 plus 8 is 33. So 33 minus 6x and 15x is 21x. So 33 minus 21x is minus 30. Minus 30. So we can write, if I take 21 here, this side it would be plus. So 21x is what? If I take minus 30 here, it would be plus 30. So 33 plus 30, which is 63. So 21x is 63. So x is what? X is 3. So this is the solution to the equation. So the solution to the equation is x is 3. So solution of this equation. By now you already have a very good idea about how you can solve the problems regarding the mathematical concept of algebraic fractions. So in the next video I'll come up with another new interesting topic, so stay tuned for that.